Go ahead and start today's lesson by going through these bell ringer problems. You're going to solve and graph the following inequalities. You get the solve and graph negative 10 is less than or equal to negative 4 minus 2x is less than negative 6. And you'll have to solve and graph 4n minus 1 is less than 3 or n plus 4 is greater than or equal to 7. Go ahead, pause the video, work through each of these problems, and when you're ready, unpause the video to get the solutions. So here are the solutions to each of the problems. Number 1 is 3 is greater than or equal to x, which is greater than 1. And when we graph that, we have an open circle at 1, close at 3, and the shade in between. Number 2 is n is less than 1 or n is greater than or equal to 3. We'll have an open circle at 1, shade to the left, and a closed circle at 3 and shading to the right. Today's lesson, we're going to be talking about solving absolute value inequalities. And to do that, we're going to first look at the absolute value of x is equal to 4. And we're going to graph those solutions on the number line. So we know that the absolute value of x equal to 4 has two solutions. Because if we take the absolute value of 4, we get 4. So we know that x is equal to 4. Or if we take the absolute value of a negative 4, we will get 4, so x is equal to negative 4 is also a solution. And then to graph those on a number line, well, we just have to put a point at negative 4 and 4. So with that in mind, we're going to ask the question, what does the absolute value of x is less than or equal to 4 ask us? And we're going to graph what it will look like. So this is asking us, this absolute value of x is less than or equal to 4 is asking us, what numbers have a distance from 0 that is less than or equal to 4. So we're trying to find out what numbers have a distance from 0 that is less than or equal to 4. And I think it's easier to think about that with the graph. So we know that since we're doing a less than or equal to, we know that negative 4 and 4 have a distance from 0 of 4. We know that. Now we need to think about, okay, which numbers on our number line have a distance from 0 less than 4. Well, if we look at these numbers here, we know, well, those are too big. The distance is too big. They're too far away from 0. But if we look at the numbers in between the 4s, the negative 3s, the 0s, the 2s, those all have distances from 0 less than 4. So we will shade the numbers in between 4 and negative 4. And if we look at 5 and 6 and above that, we can see that those distances are too far from 0. So, well, let's look at what kind of graph this is. This is an AND graph because the lines are connected, it's in between. So this is an AND graph. We're going to have to remember that for a little bit later. Now let's answer the question, what does the absolute value of x is greater than or equal to 4 ask us? And then it asks us what numbers have a distance from 0, this time greater than or equal to 4. So what numbers have a distance from 0 greater than or equal to 4? Again, we know that negative 4 and 4 have a distance from 0 of 4. So we know those are going to be in our solution. Now, to show where the numbers that have a distance greater than 4, Well, this time we're going to shade to the left of -4 because those numbers, the -10, the -6, and -5, those are all farther away from 0 than the -4. And also we look at 4, we want to shade to the right of that because those numbers, the 5, 6, the 20, stuff like that, are going to have a distance from 0 greater than 4. And if we notice, we can look at what kind of graph this is, and we can tell that it is an OR graph. So what we just found out, ladies and gentlemen, is that we have an absolute value equation or inequality, and it's a less than inequality. We know that it will produce an AND graph. And if we're talking about a greater than absolute value inequality, it will produce an OR graph. So with all that we just talked about in mind, we're going to talk about solving some absolute value inequalities. And we're going to start that by talking about solving the less than absolute value inequalities. We just showed that when we have a less than absolute value inequality, we will know that it will be an AND statement. So when solving absolute value inequality, the absolute value of 3 plus 3a is less than or equal to 24. We will write an AND compound inequality that will have what is inside the absolute value less than the original number and greater than the negative of the original number. Now let's talk about what that means. So if we look at the absolute value of 3 plus 3a as less than 24, we want to have what is inside the absolute value. So the 3 plus 3a, it is going to be less than the original number. So less than or equal to 24. And then it will also have to be greater than the negative of the original number. So we'll take 3 plus 3a, and it needs to be greater than or equal to the negative of the original number. So negative 24. And since it's an AND statement, I will put AND in the middle between these. So I just made two inequalities. 3 plus 3a is less than or equal to 24, and 3 plus 3a is greater than or equal to negative 24. So in a way to remember this, that with a less than you have an AND statement, I always just say in my head, if I have a less than, it's going to be AND, less than AND. Now I can just solve each of these inequalities. So the first one, I'll subtract 3 from both sides. I get 3a is less than or equal to 21. Then divide by 3. And I get a is less than or equal to 7. Now I'll go to the other one. Again, subtract 3 from both sides. 3's on the left cancel out. And I'll be left with 3a is greater than or equal to negative 27. Divide by 3 on both sides. And I'm left with a is greater than or equal to negative 9. So, ladies and gentlemen, with that I can make one inequality, a double inequality, with my smallest number first. So the negative 9 is first, so negative 9 is less than or equal to a, which is less than or equal to 7. And then there is our AND statement. Now let's go ahead and graph each of the inequalities. So a is less than or equal to 7. So I go up to my graph. I have a closed circle at 7. And I know I'm going to the left. And then I need to be having a closed circle at the 9. And then I'm shading to the right. And then that will connect my 2 points. So there is our solution to this. So remember, when we have an absolute value inequality and it's a less than, we're going to have a less than and. So we're going to produce an and statement by being less than the original number and then greater than the negative of that. Now, I apologize. With this slide, we have to make a few corrections. So this time we're going to be solving a greater than absolute value inequality. So we're going to look at solving a greater than absolute value inequality. And when we have a greater than, change that to a greater than absolute value inequality, we will know that it will be an or statement. It will be an or statement. And then go ahead, change the 7v plus 7, the absolute value of 7v plus 7, make that just a greater than 14. So sorry about that. So we're going to be solving the absolute value of 7v plus 7 is greater than 14. And we know that we are going to have an or statement. We're going to have an or statement. So when solving this inequality, we will write an or compound inequality that will have what is inside the absolute value greater than the original number and less than the negative of the original number. And that'll look like this. So we have 7v plus 7, so what's inside of the absolute value greater than the original number, which is 14. Then we will take what is inside the absolute value, the 7v plus 7, and we will make it less than the negative of the original number, so negative 14. And then now we know that this is going to be an or statement, so I can put or in the middle. Now I just need to solve each inequality. So subtract 7 from both sides, and I get 7v is greater than 7, then divide by 7 on both sides, and I get v is greater than 1. And going to the other inequality, again subtract 7 from both sides. I get 7v is less than negative 21. Divide by 7 on both sides. I get v is less than negative 3. So my solution to this is v is greater than 1 or v is less than negative 3. And let's go ahead and graph that. So I will graph an open circle at the negative 3. Since it is less than, I will shade to the left. And I will have a open circle at 1. Since it is greater than, I will shade to the right. So what we need to remember is if we have an absolute value inequality, if it is a greater than, it will be an or statement. And we will be greater than the original number, then less than the negative of the original number. So let's get a couple solid examples on here, get some more practice so we know what we're doing before we get to the huddle. So the first one is absolute value of x minus 7 is less than or equal to 14. So since I see a less than or equal to here, I know since it is a less than, I know right away I'm going to have an and statement. So I'll have an and inequality statement. So, since it is a less than and statement, I will take x minus 7. It is going to be less than or equal to my original number because I'm looking for the distance that is less than 14. And then I will have and I want the distance to be greater than or equal to the negative 14. So what is inside the inequality needs to be greater than or equal to negative 14. Because when we have a number that is greater than or equal to negative 14, that distance, those numbers will be less than 14 away from 0. So now I just need to solve each of these inequalities. So I can add 7 to both sides. and I get x is less than or equal to 21. And over here, I'm also going to add 7 to both sides. I get x is greater than or equal to -7. So I can rewrite that as a compound inequality with my smallest number first, -7. What's in the middle? X. And what is last? What's 21? I'm going to have some less than or equal to symbols. So my final solution is -7 is less than or equal to x, which is less than or equal to 21. Let's go ahead and look at the other problem now. We have the absolute value of x plus 2 is greater than or equal to 5. We have a greater than symbol, so we know that we are going to have an or statement. A greater than tells us we have an or statement. So I need to be greater than my original number, so x plus 2 needs to be greater than or equal to 5. And then I need to be less than the negative of my original number. So less than or equal to -5. Go ahead and solve each of these inequalities. So subtract 2 from both sides. I get x is greater than or equal to 3. Subtract 2 from both sides on this one. I get x is less than or equal to -7. And since this is an or statement, I just need to throw an or in between, and then I'm good to go. So with that, go ahead and work on these two huddle problems. To get you started, notice the first one is a less than or equal to. So I will have a and statement as my answer. And the second one is a greater than sign, so I'll have an or statement as my answer. So go ahead and solve each of these absolute value inequalities. Pause the video whenever you're ready. Unpause it to get the solutions. So the solution to the first one is -5 is less than or equal to m, which is less than or equal to 6.3 repeating. And when you graph that, you have closed circles at -5 and 6.3, and you will shade in between. The second one, the solutions are k is less than -6 or k is greater than 0 with an open circle at 6 shading to the left and an open circle at 0 shading to the right. So with that, go ahead and complete this mastery, work through each of the problems, and then check your answers. So pause the video now, and whenever you're ready, unpause it. Alright, so here are the solutions to the mastery. Go ahead and check them, and then make sure you're right. That finishes up for today's lesson. Go ahead and get started on your homework, and have a good night.